Okay, this is our last video in our sensitivity adventure. Um, we're going to look at changes to the column of a basic variable. First, looking at changes to the objective value for a basic variable, and then changes inside the column for the basic variable as well. So the main thing to note is that if we change the objective value for a basic variable, then that CB transpose changes as well, okay? And so let's think back to, let's think about what is our basis, and we're going back to the original problem. So our basis is x1, x2, and slack for demand. Okay, so these are our basic. Maybe I'll note as well, our non-basic variables are slack for finishing and slack for carpentry. Those ones are both set to 0. Okay, so we're looking at a change to the profit for toy soldiers, which would change C1. But let's talk about let's do it in general, and then we'll look at this specific change. Okay, so if we're changing this is for one of our basic variables. So CB transpose is going to have you got to look at the order of your basis. Okay, and so order matters, and that's based off of the order of the kind of standard basis vectors. And so looking back at this problem, the final tableau here, our basic variables are ordered as far as row wise as x1, x2, and SD. Okay. In this case, we're not considering Z as part of it because it's sort of its own separate thing. Okay. And so our CB transpose vector is going to be C1, and if we change it, we'll put a bar on top of it, C2 bar, and then our slack variables don't have any original cost to them. They'll have eventually the objective values underneath them will become our dual variables after we've kind of done our steps, but at least originally they've got 0 for their original coefficients in the objective vector. Okay, so that's our CB transpose vector, and we could think about changes to either C1 or C2 here. This plays into giving us a new Y transpose vector. And so our dual variables depend on the value in the objective row of the basic variables. And so this is equal to CB transpose B inverse. Okay, the B inverse matrix is not changing right now because that takes the columns underneath the basic variables, but not the objective. Okay, and so B inverse isn't changing yet. And we can read off our B inverse matrix directly from our tableau. That's right there. And so this are dual variables. We can think of these in terms of C1 and C2 and 0. And then we'll multiply by that B inverse matrix, which is 1, -1, 0, -1, 2, 0, and -1, 1, 1. Okay, doing that multiplication, that will give us, multiplying this row vector down this column will give us C1 bar minus C2 bar. 0 means that we can essentially ignore this last row here at the end of this one. Then we'll get negative C1 bar plus 2C2 bar, taking this times the second column here. And then this last column, you'll get 0 times C1, 0 times C2, and 0 times 1. And so this last one is equal to 0 there. Okay, and so it turns out in this scenario, no matter what we choose for C1 and C2, the dual variable corresponding to the demand constraint is 0. And that's because, well, the slack for demand is in our basis, And so that means that there is some slack for that constraint, which means that constraint is not active. And so it's going to have 0 for its shadow price. There's no value to increasing the demand for soldiers if we're not making the full 40 units of soldiers right now. Okay. So those are our dual variables in terms of changing to C1 and C2. Okay. Now let's think about, okay, what else changes in here? And so looking in here, if CB changes, then Y transpose changes. And so here I'll point out the places where Y transpose affects these things. It doesn't affect any of the rows here, okay? And so it doesn't affect feasibility, but it does affect the objective row, okay? And so it will show up here, it will show up here, and it will show up in the objective value as well. And so here and here, that's affecting optimality. And so let's write down our optimality conditions, and those are going to be what we need to check. We need to check that it's still optimal. And so we need to check that Y transpose is greater than or equal to 0, and that the reduced cost Y transpose A minus C transpose, and I'll maybe put a bar on that one too, because those C values have changed, is greater than or equal to 0. Okay, these are essentially all the dual constraints. Okay, we need to check all the dual constraints because that will give us primal optimality. Now, there is a nice thing about this in that we don't actually have to check all of them. We only have to check the ones corresponding to non-basic variables. Because the ones corresponding to basic variables, if you do check them, they're going to end up perfectly equal to 0. Okay, and so in this case, SD is a basic variable, and we already saw that no matter what we do to change C1 and C2, that third dual variable that has a value right there is sort of locked in at 0 no matter what C1 and C2 are. Okay, and similarly, these two values, which are what we get from Y transpose A minus CT, those are going to be also locked in 0 if we check them. And so we only need to check the dual constraints or the kind of optimality conditions for the non-basic variables. Okay. So we'll maybe write that non-basic variables only. Okay, and so this would be there's essentially 3 of these and 2 of these, and so kind of 5 total variables, original and slack variables. So there'd be five constraints to check, but really only 2 of them are for non-basic, and these are actually the only 2 that are for non-basic here and here. Okay, and so let's actually look at that, and we'll focus on C1. And so we'll do changes to C1. Okay, I need that this is going to be greater than or equal to 0. And so I've got C1 bar minus C2. The original value for C2 was 2, and that has to be greater than or equal to 0. And then this one is negative C1 bar plus 2C2, so plus 4 is greater than or equal to 0. Okay, rearranging this one says C1 bar is greater than or equal to 2, and this one, if I move it around, says that 4 is greater than or equal to C1 bar. Putting these together, for between 2 and 4, our current basis will remain optimal. So if the profit for soldiers is between $2 and $4, we'll keep our same basis, okay? And what I'll note is, since we're only affecting the objective values, we're not changing our actual solution. And so we'll continue to make exactly 20 soldiers and 60 trains, okay? As long as yeah, C1 is between 2 and 4, our current solution is optimal. Okay, which actually answers the original question. What if it's 3.5? Well, 3.5 is between 2 and 4, and so it's currently optimal. Okay, but our solution won't change, but I will say our profit will. Okay, and so let's look at what our new profit is. And so Z bar equals Y bar transpose B. Okay, and our new Y bar, well, let's do it for the specific change of 3.5. And so this is going to be 3.5 minus 2. And so that's going to be, maybe right, 3.5 minus 2. I'll write them out. And this one will be negative 3.5 plus 2, or negative 3.5 plus 4, and 0, multiplied by our right-hand sides of 100, 80, and 40. And that gives us, so this is 1.5 times 100 is 150. This is a half times 80, and then 0. So 150 plus 40 is 190. Okay, previously our objective value was 180. Here we've increased the profit for one of our products without actually costing us any more in our resources. And so our objective value has increased. We'll notice that our current solution would also be optimal if we reduce the profit from soldiers, in which case then our objective value would decrease there as well. So yeah, it's not maybe 100% obvious because C1 shows up as a positive here and a negative here, but overall reducing the profit for that will reduce our overall objective value. I guess maybe another way to note this is that another way to write Z, maybe I'll kind of write that off here, is that Z, well, it's CB transpose B inverse B, and we can group B inverse B there together. And so it's CB transpose times XB. Okay, and this XB is not changing. And so maybe it's a little bit more obvious to see that Z would be equal to the CB transposes C1, C2, and 0. Up here, XB currently is this column here, 20, 60, 20. And so it's going to be 20 times C1 bar plus 60 times C2 bar. Okay, and so if we were to make small changes to C1 and C2 such that this remained optimal and we could look at what the changes to C2 are, then this is sort of the formula for our profit, because we're making 20 soldiers and 60 trains in it. So kind of reducing the profit for one of these kind of reduces the overall profit. Okay, so that's changes to the objective row for a basic variable. What about changes inside the column for a basic variable? Well, if you change inside the column for a basic variable, then you change the B inverse. And then the B inverse or the B matrix is going to be needed to be inverted. Inversion is not a linear transformation. And so whereas all of like kind of the previous ones, we've ended up with nice inequalities that are kind of linear inequalities, and everything's kind of nice. If you make changes to the values in the columns of a basic variable, then essentially everything changes. And not only does it change a little bit, but it changes non-linearly, which means that it's not really easy to deal with. And so Whereas we were able to kind of have kind of limits on how much you could change any of the other parts of it. If you change something that's in the basis column, it really does affect everything, because then it's going to change the B matrix. You'll notice B inverse shows up here, here, and here. And B inverse shows up in the dual variables. So really it's showing up here, here, and here as well. And so the whole tableau changes if you change one of the columns there. And so for small changes, there's sort of, you could kind of recompute B inverse and sort of redo your transformation and check, are you still feasible? Are you still optimal? And that maybe wouldn't be too hard. But for larger changes, often it's best to sort of solve from scratch. Yeah, so there's maybe less to say about this case because it's maybe the messiest to deal with. And so it might be worth just resolving from scratch. There's maybe some shortcuts, but they're maybe so long of shortcuts that they're not really worth talking about as a shortcut. So that concludes this video on changes to values underneath a basic variable, either the objective value or the values in the columns.